Before the factory, the journey begins in the vineyard, where timing the harvest ensures maximum sugar content.
Mechanical harvesters mimic the action of hand-picking, but at an industrial scale, shaking fruit loose without damaging the vine.
Catch plates below the vines funnel the loose fruit onto conveyors, immediately separating it from the ground.
Once the transport bins are full, they are immediately rushed to the processing facility to prevent premature fermentation.
Speed is critical. The fruit must enter the processing line within hours of leaving the vine.
At the receiving dock, the raw load is weighed and logged before entering the initial cleaning stage.
The intake hopper acts as a surge buffer, feeding the processing line at a consistent, controlled rate.
Elevators lift the raw product to the pre-cleaning tower, where gravity and air will do the heavy lifting. While automation handles the bulk, human inspection ensures large contaminants don't damage the machinery downstream. A water flume transport system serves two purposes: gently moving the fruit and beginning the rehydration and cleaning process.
Agitated wash tanks loosen stubborn field soil and residues before the drying process begins.
A final freshwater rinse ensures the fruit is completely free of sediment before chemical treatment or drying.
Cleaned and sorted, the grapes now approach the critical decision point that will determine their color and texture. To create golden raisins, the fruit is routed away from the natural drying line and toward the pre-treatment facility.
Specialized dipping oils are added to the mix, acting as a surfactant to ensure the solution coats every contour of the fruit.
This alkaline emulsion is pumped directly to the dipping station, where it must be maintained at a precise concentration. Automation systems constantly monitor the pH levels, ensuring the chemical reaction will be effective without damaging the fruit's flesh. Grapes naturally possess a waxy cuticle that locks moisture inside, preventing rapid dehydration. To speed up drying and preserve the golden color, this waxy layer must be cracked microscopically.
Temperature control is vital. Too cold, and the wax remains intact. Too hot, and the fruit cooks.
The emulsion works by causing fine cracks in the skin, creating exit pores for the internal water.
With the chemistry balanced and the temperature set, the pre-treatment line is fully engaged. The facility creates a continuous flow, processing tons of raw fruit every hour during the peak season. Efficient recirculation systems minimize chemical waste while maintaining constant coverage on the belt.
Without this step, drying would take weeks. With it, the process is reduced to mere hours.
Even distribution on the belt is critical for the chemical reaction to be uniform across the entire batch. Fully prepped and graded, the fruit now plunges into the alkaline bath that defines the golden raisin.
Upon impact, the grapes are instantly enveloped by the hot potassium carbonate solution.
Total immersion is guaranteed for 6 to 90 seconds, a precise window to alter the skin without cooking the flesh.
The heat and alkalinity work together to dissolve the natural waxy cuticle that seals moisture inside the berry.
As they emerge, the skins are now microscopically porous, allowing water to escape rapidly during the drying phase. Air knives remove the bulk of the moisture, ensuring the chemical residue is minimal and uniform.
To the naked eye, the fruit looks merely wet, but the structural integrity of the skin has been fundamentally compromised. Quality control technicians verify the checking of the skin physically. If it splits too easily, the solution is too strong. The system automatically replenishes the dipping oil, consuming liters every hour as the fruit carries the coating away. Maintaining heat is energy intensive, requiring a constant supply of industrial steam to the jacketed tanks. Surface sanitation is the final step of the wet process, neutralizing any bacteria brought in from the field.
Cleanliness around the dipping tanks is paramount, as the alkaline solution can be slippery and corrosive.
To achieve the golden color, the fruit must not only be dipped, but also exposed to sulfur dioxide to halt oxidation.
The dipping process is complete, and now the fruit moves into a controlled environment to lock in the pigment.
Without this chemical intervention, the grapes would naturally brown like a sliced apple exposed to air.
But for this batch, the process is continuous, feeding the dehydrators without pause.
For natural dark raisins, the chemical dipping stage is bypassed entirely, preserving the fruit's organic integrity. Here, the goal is slow, natural oxidation, a process that requires the grapes to be laid out rather than submerged. Industrial tray loaders ensure a continuous supply of clean surfaces for the incoming fruit. Careful loading is essential. Fruit piled too high will rot before it dries. Mechanical levelers guarantee maximum surface area exposure for every single berry. Human oversight remains the final fail-safe to prevent debris from entering the drying yards. Specialized tray designs include built-in spacers, creating wind tunnels for airflow even when stacked.
Once stacked, the fruit is immediately mobilized for transport to the drying zones.
Unlike the dipped raisins, these retain their natural wax, which slows the moisture loss significantly.
In larger operations, continuous paper trays laid directly on the earth serve as a cost-effective alternative to wood.
This method relies on the ambient environment, converting solar energy into a slow, caramelizing heat. Without the chemical cracks in the skin, these grapes will take weeks, not hours, to reach the desired moisture content.
It is this prolonged oxidation that converts the green pigments into the deep, rich, black-brown of the classic raisin.
Whether on trays or the vine, the natural process is a gamble against the weather, requiring constant vigilance.
While the natural fruit waits for the sun, the golden raisins enter the dehydration tunnels to bypass the weather entirely. Artificial dehydration offers total control, creating a consistent environment that nature cannot replicate. Powerful gas burners generate the thermal energy required to evaporate tons of water rapidly.
High-velocity fans force this heated air through the stacks of trays at speeds up to 600 feet per minute.
The airflow removes the boundary layer of moisture surrounding each grape, accelerating the evaporation rate.
Operators utilize a counterflow system, where the driest air meets the driest fruit first to prevent case hardening. Over a period of 24 hours, the fruit loses 80% of its weight, shrinking down to its final sugar-dense form.
Humidity control is critical. The moisture pulled from the fruit must be constantly exhausted to keep the air thirsty.
While traditional racks use natural shade and wind to preserve color over weeks, the tunnel achieves this in a single day.
Visual inspection confirms that the raisins have reached the target texture without burning or caramelizing too deeply. Once the moisture content hits roughly 14%, the heat is cut to prevent over-drying.
The tunnel is purged, and the trolleys, now holding the finished golden raisins, are ready for extraction.
The result is a plump, golden raisin that retains a distinct tartness due to the preservation of its acids. While the factory-dried fruit cools, the natural sun-dried crop outside is finally reaching the end of its much longer journey. Outside, under the direct intensity of the sun, the natural process takes place on a massive agricultural scale.
Over 2 to 3 weeks, ultraviolet light and heat drive the moisture content down from 80% to under 15%.
Field inspectors monitor the texture constantly. If harvested too wet, they will mold, too dry, and they shatter during transport. To ensure uniform drying, the fruit must be turned halfway through the process, exposing the underside to the heat.
This open-air method is effective but exposes the product to dust, insects, and grit, which must be aggressively removed later.
Once the moisture target is hit, the harvest begins, consolidating millions of individual berries into bulk transport bins.
Preliminary field cleaning removes the largest debris, but the raisins remain coated in fine field dust.
These large crates, known as sweat boxes, become the storage vessel for the fruit during the next critical phase. The sun-dried raisin is tougher, with a caramelized flavor profile distinct from the tart golden variety. Logistics teams coordinate the movement of thousands of bins from the scattered fields back to the central processing plant.
The journey returns to the factory, but these raisins are not yet ready for packaging. They are too dry and uneven.
Upon arrival, the fruit is extremely hard, with moisture levels varying wildly between individual raisins.
To fix this unevenness, the raisins must enter a stabilization period known as sweating or equilibration.
Stored in these sweat boxes, the moisture naturally migrates from the wetter berries to the drier ones.
This resting period can last for weeks, ensuring every raisin has a uniform texture before mechanical processing begins.